Good afternoon and welcome to this webinar on the subject of Eco-Mechatronics. My name is David Bradley and I'm going to act as the coordinator for the session, or the webinar. There will be two presentations. The first will be given by Professor Peter Henberger from the School of Engineering at the University of Applied Sciences of Austria, where he's head of the Smart Mechatronics Engineering Research Group and the academic director of the Institute of Agile Transformation. His research interests include sustainability in development and production of mechatronic systems, engineering processes, and also topics in digital transformation. The second presentation will be given by Professor Maki Habib from the American University of Cairo, where he is the professor of robotics and mechatronics, having also worked extensively in those areas in Japan, Malaysia, and Australia. His current research is focused around the application of mechatronic and robotic systems in areas such as autonomous vehicles, manufacturing technologies, including Industry 4.0, and nanorobotics. I'll be handing over to Peter Henberger for the first presentation, and we'll take questions, as I said, following both presentations. I'll be monitoring the questions as they come in, so please get them to us as quickly as you can. So, Peter, over to you.
Hello, David. Thank you for the introduction. I will share my screen. Can you see my slides?
I can, Peter. I can see your slides.
Okay, thank you, David. Good afternoon, also all participants. It's a pleasure for me to give you an introduction to the term paradigm Eco-Mechatronics. What is we will discuss what is Eco-Mechatronics, what are the concepts, objectives, and possibly the outcomes. If we look at our background, our constraints, we have a lot of activities on sustainable development and also to improve the well-being of people on world, on the environment. Maybe you have also heard from the European Green Deal. And now it will be for us important, how can we help companies in their mechatronic design process to improve their products, services, and also production systems. If we discuss about sustainability, we have to focus on the three dimensions. We have to focus on the environmental aspect, the social aspects, and also the economic aspects. And always we have the interaction between these different three dimensions. There already exists a lot of methods for analyzing the sustainability of products or services. One method, which is well known, is the life cycle assessment, where you want to analyze the impact of product. You have typical steps like the goal and scope definition. Then you have to invent all aspects, all data, and then you have to analyze the impact of this product and also to interpret for your daily work in product development and strategy planning what you can do with this aspect. On the other side, the question will be, how can mechatronics help it? And if we look on global greenhouse gases emission, for example, I have a diagram from Austria that that 50% of the CO2 emissions are coming from the production manufacturing industry and also from the traffic. And here also mechatronic systems can help us. Another important aspect is what we have to consider is how can I manage the environmental indicators, which indicators are necessary for the different aspects, like we want to focus on the carbon footprint, land use, air pollution, and so on, or if we only focus on the results, the global average temperature. And also we have economic aspects. We have a price for CO2 emissions, especially if you can see a chart from Austria in the last years. How can mechatronics help this? Mechatronics is the integration and interaction of the different disciplines like mechanical engineering, electrical engineering, IT, control design to help to improve promoting a cleaner future and especially to reduce, and this is one aspect of Eco-Mechatronics, the ecological impact of such mechatronic systems during their whole life cycle. Also, the vision of Eco-Mechatronics is to improve the human behavior and also the quality of life. Currently, we have some transformation processes in industry. For example, 10, 20 years ago, we're starting with digital transformation. You know it as the term smart manufacturing or Industry 4.0. This is also, from our point of view, an enabler for the sustainable transformation. These two terms are also called green transformation. And also we have to modify, to analyze the different processes, different technologies, working with knowledges in companies, and so an agile transformation process is also very important. And therefore, Eco-Mechatronics help to support these different transformation processes in companies. And here also the different environmental aspects are represented. You can see in the figure on the right, we have the focus on the global environment. Also a very important task, what I want to discuss with you later, circular economy, the design process, and also the net zero goals. So Eco-Mechatronics can be a sustainable model for the design of environmental friendly products, processes, and systems. If we go in more detail in Eco-Mechatronics, it is always very important to analyze the whole life cycle of a product, to have a holistic view on all life cycle stages. You can see here the 5 main stages in a life cycle of a product. You will start with the planning process, where you have strategic planning, where you define the concept of your product. Then you have a very important phase, it's the engineering phase of our product, where some methodologies on eco-design can help. Afterwards, you have the productions of the product, of the mechatronic system. Then you have the usage, where you also need some specific monitoring service systems. And at the end, you have the end of life of our product. You have also the same phases in, if you focus your product will be produced by a production system, you have the same phases in the life cycle of a production system. You have to planning this system, you have to engineer, and also then you have the interaction between these two life cycles in the operation phase. And also, this is for environmental aspect very important. For the production of our product, we need energy and also we need materials. And therefore, it is also a very important loop to use these materials for the production. Then you use the product, and at the end of life, you will reuse these materials. You also know the term circular economy. And now, from our design point of view, the early design phases of a mechatronic system are very important because we have a high freedom of action to improve, to influence the environmental properties of the mechatronic product. But this is also a challenge for us. The knowledge which we have about the product is very poor. But in this conceptual design phase, we make the main decision for the success of a product and also the environmental impact of the overall system. And now Eco-Mechatronics can help us to improve the decision process in this early design phases. If we discuss about mechatronics, you know this figure in a typical mechatronic system. We have a basic system. It can be a mechanical system, a chemical system. Then we have some sensors which analyze the conditions of our system. And on the other hand, we have actuators which drive our systems. And then in the virtual or cyber room, we have the information control of this system. So typically, a mechatronic system is the interaction between these different disciplines. We have some aspects on the physical parts of the system and some aspects on the cyber part of the systems. In larger systems, this is our we have not only one mechatronic system, one production system, we have a network of production, for example, of production systems, and this network is physically connected and also has an integration network of computation. Therefore, the term cyber-physical systems will entsprechend used. And if I connect all the systems, then the term systems of systems is used. These are some aspects of the digital transformation of mechatronic system. Why is this important in the eco-mechatronics paradigm and for environmental aspects in a system? I give you a simplified use case. At the right side, you will see the systems of mechatronic system. It starts with the mechanical system, the car, then with all additional functionalities, and also then the interaction to other systems like home systems, traffic management systems, and so on. And in this simplified use case, which was prepared from David, you will see that in Cities like San Francisco, 20 to 30% of the traffic is only by people looking for a parking place. And now such a digital system can help to reduce this traffic uh, in such cities and helps the environment also to reduce the carbon footprint. On the other side, Eco-Mechatronics, the paradigm Eco-Mechatronics is also the evaluation of different applications. If you look at typical mechatronic 50 years ago, you have some systems, sensor systems, industrial robots. Now we will go more to a cyber part, also to integrate virtual models related to a cyber physical system. And afterwards, you can go to cloud-based systems, Internet of Things, where Eco-Mechatronic is one building block to support this aspect, like smart cities, smart home, what I have shown, autonomous vehicle. On the other side, it is important that we also taking into consideration the modeling and simulation techniques. Therefore, the term digital twin exists. Digital twin means the interaction between the cyber world, the data, the models, the information, and the physical world. And between these two worlds, I have always an interaction to describe the properties of the system, to analyze the real condition of our mechatronic system on different system levels. And therefore, it is also possible to predict the system properties in advance for the future. This is also a very important aspect which helps Eco-Mechatronics. At the end of the presentation, I want to give you a quick overview about one possible use case. I will present you some activities of the Horizon 2020 project, Energy Efficient Manufacturing System Management, which helps, and you can see here, to reduce the energy consumption during the production of different systems. Maybe you know terms like factory of the future. Therefore, we have also what I mentioned before, to integrate all different aspects of digitalization to get an energy sustainable solution related energy consumption, energy costs, and also to CO2 emissions. If I look at my clock, then I have only 1 minute to show you some details of this project. You also can find a lot of information on the website of the project, where the goal will be that the factory is a living organism to reduce energy and also costs in a production plan. Therefore, the overview, the approach which will be used, we have discussed before. One important aspect is to have information, data from the industrial system, like a cyber physical system. Then you need models to simulate the process and also to predict the energy flows in the future. And at the end, you have to integrate all this data in a, maybe with big data analytics, to have a decision support to support all decisions during the production process. And this example, this project show you that the different aspects of Eco-Mechatronics are used there to reach a sustainable solution for a production system.
Thank you
So
very much indeed,
I'm,
Pete.
so I'm at the end of my presentation. It was my goal to give you an overview about the paradigm Eco-Mechatronics and how can it helps in different use cases.
Thank you very much indeed, Peter. So we now need to hand over to Professor Maki Habib. While that is taking place, could I just remind the audience out there that you can submit your questions at any point in time rather than wait till the end of both of the presentations. So if you have any questions, then please submit them when you think of them. And I'll now hand over to Professor Habib.
Thank you, David, and good afternoon and good morning and good day for all of the attendees from any part of the world. The title of my presentation, following up Peter's presentation, actually, it is still within Eco-Mechatronics, but I will tackle it from the principle of why and impact and the future prospects of the field. My name is Maki Habib, and I'm from the American University in Cairo. Starting from the global problem facing the humanity and why there is a need for Eco-Mechatronics. If we tackle the brief listing of the top 10 problems facing the world and the humanities, we can see the natural resource depletion is a key element, and that's why people are looking for a sustainable solution in many dimensions. You have the climate changes, global warming, as a result of many activities, and part of it is the emission of the CO2. And the pollution in the air also is contributed by the traditional industry mainly, and the pollution in water. We have the water shortages that's impacted also through the weather, etc. We have the soil degradation that affects the agriculture and that affects later on the food chain. And all of these actually also are linked directly to the ecology and the loss of biodiversity, because any effect on the water shortage or degradation of soil or pollution or climate change, that's affect directly on the ecosystems and would have a negative impact on the biodiversity. Also, the deforestation, when you're removing the tree are essential element actually that integrating into its life cycle a lot of species and ecosystems, and removing them is heavily affecting the environment and the chain in the ecosystem itself. We have the ocean acidification due to the release of a lot of polluted chemicals, the overpopulation in the world and the demand for space and all of lifestyles that support such populations. And we have the waste disposal. In general, there is a lot of effort to reduce its effect, but still it is considered as unsustainable waste technology. So from that, we can look into the why of the Eco-Mechatronics. And I was trying to put a definition, but for the definition is not the definition. It is because the field is still at early stage and still open to be evolved and having its shape in a good way through the activities of many researchers in the field. But I can state that the Eco-Mechatronics can be defined as it is as interdisciplinary and visionary field, evolving to a holistic impact on the development of current and future technology. And such a future technology may include smart technologies, may include also methodologies, algorithms, technique, product, systems, and processes. While developing this, the focus is going to be on the sustainability, ecology, economic, and circular economy. The circular economy is playing the role of the management to facilitate the management for a better or to maximize the outcomes of the effort in such a development from the Eco-Mechatronics side and the reflection on the sustainability, ecology, and economy. And to achieve this goal, there is a need to develop novel design strategies supported by creative thinking leading to new ideas. So here, the Mechatronics is associated also with the new thinkings and associated with the development of innovative new ideas. The aim is to address interdisciplinary challenges with a potential synergy where in experience and way of work, in technology and in knowledge. And all of that are going to contribute to optimize the design development process and maximize the functionalities. So the synergy here is leading to develop a new energy efficient, renewable and clean energy, economical, sustainable, waste reduction or elimination. The target actually of the Eco-Mechatronics is not just to reduce, it's to eliminate, but along the process, it can be go into different stages and to have environmentally friendly technologies in general. Once again, the circular economy concept is playing a key role to combine all of these efforts that are going to facilitate and manage the outcomes leading to ecologically sustained society. So when you talk about the evolution of the Eco-Mechatronics, already we are feeling it and sensing it and seeing it growing gradually, is to support the effective design and development of Eco-Mechatronics product system and processes. And the vital issues that we need to understand through this process is the application, the consideration of the application, the ecosystem, the environment, sustainability, and the econ management for effective outcome. Because all of the problem facing the world actually that has a direct effect on the ecosystem. An ecosystem, when you are developing a technology, the consideration of the ecosystem is very critical because that will tell us and guide us about the whole process of the contribution of the developed technology on the environment, and also the cycle time of such a technology within the ecosystem consideration. So this actually consideration effectively facilitated through intensive analysis associated with study and observation of the natural system, because nature will be a very good lesson and model for us. Is to consider the goal, and that is aiming to have a conscious conclusion to emulate nature's best properties and functions. And the nature actually include all physical systems that we can learn and understand and reflect out of it to support the development of new technologies, specifically led by the Eco-Mechatronics field. And therefore, it is essential to understand the conditions that allow an approach to produce creative design. And this creative design leads to creative ideas, functions, and systems. And creative design by nature is a potential way to support environmentally friendly and innovative technology development. All is aimed is to have a net zero emission and waste in general. And we are aiming to, through this technology actually, or through this field, to show that the Eco-Mechatronics is going to contribute to this goal and the development for the Eco-Mechatronics products and system demands to have a whole for the purpose of having a net zero Eco-Mechatronics is to have a whole integrated system thinking covering both technical, social, and environment. This issue is going to be managed properly through eco system management. In contrast to life cycle design normally it is influenced by the view of considering energy, material, and lifetime of them without linking the matter with the ecosystem and subjected to the eco management and social aspects of that. So we need to think about actually what kind of current evolving technology that's going to support the evolution of Eco-Mechatronics. So we have many aspects of technology that are currently used, and they are evolving, some of them, and some of them are still in the early research of the development. So these technologies, I'm categorizing it in five groups. The group one is related to the computing. So we have a distributed and optical computing, DNA data storage, miniaturized computing technologies, molecular computers, neuromorphic computers, quantum computers, etc. And we have the digitalization, where there's a huge effect and focus on the digital transformation. And this will include a lot of domains in the artificial intelligence, blockchain application with relating to that, cybersecurity and privacy protection, digital twins, real-time insight, optimization and decision making. You have human-machine interaction that support a lot of issues, and one of them is related to the robot and robot autonomy. We have smart cities and urban mobility, virtual augmented reality, wearable devices, etc. And we have another categories that supporting as enabling technology for Eco-Mechatronics is the artificial intelligence domain in general that include very wide range of activities, almost involving in all domains of the development related to the smart, intelligent decision-making, machine learning, real-time learning, deep learning. We have autonomous, well, obviously, seeing the autonomous cars, robots, vehicles, drones, under sea, etc. We have the big data, data analytics, and data fusion, connected device, Internet of Things, CPS, etc. Real-time interaction, and wide range of applications. Also, we have huge evolving activities and research in the domain of nanotechnologies, going to range from biophysics, micro and nano manufacturing, nano computation, nanomedicine, nano robotics, nano smart materials, and green technologies. And we have also huge development at the level of the robotics, from additive manufacturing, the use of robotics in additive manufacturing and rapid prototyping, autonomous robots in all dimensions actually of the spectrum, from air, sea, and the ground. We have heterogeneous multi-robot systems that's involving in many applications, either co-located within the same application space or distributed around the globe. We have intelligent thought mechanism to have a reconfigurable, agile, medical robots, etc. And in general, we can categorize that the huge evolution and the development of service robotics in general, and supporting human being in different dimensions, and also the development of personal robot, besides the focus of the industrial applications. And we have the development of sensor actuators that will give flexibility to different development, either robotic side or the nanotechnology side or other levels, is to give the knowledge through the abstracting of information from the working environment and the decision making into action, and this come normally from the sensors and actuators, and we have different enabling technology in this direction, coming from actuator design technologies, biosensor, bioactuator, nanosensors, nanoactuators, wireless sensor networking, sensor actuators, and smart materials, etc. Future prospects, actually, when we're talking about future prospects, the eco and sustainable design strategies are critical issues facing the development of the field. And focusing on this issue is very important. And this will come from the development of technology supporting eco-mechatronics, from the materials also that facilitated this development of such technology, the processes itself, how to make it more effective, efficient, and innovative, and developing accordingly intelligent systems that facilitating that, and with future technology applications that mainly focusing also on managing the ecosystem in order to achieve the target of the development of the eco-mechatronics itself. And such evaluation of eco-mechatronics need to focus on different area of research from now ahead in the future. And this research are an open-ended research that still currently available and continue in the future. Besides, it needs additional development that's supporting the field continuously. Some of these are listed here. I'm going to just to show you the list without involving into the details. You see it's coming from the computing level, the agile system, the intelligence, biosensors, the clean energy, and energy consumption technology to have a lower consumption technology, distributed data analysis, decision making, eco design, management, and circular economy, and to spell out about a fully autonomous system, biohybrid, robot, green technologies, and eco-friendly solutions. We have other level from intelligent adaptive behaviors, intelligent and adaptive mechanisms, machine intelligence. So we have a huge list of development is evolving, and all of these are open-ended research topics. And as I say, we are not limiting the list to this. We are not limiting the list to this, rather than it is an open-ended and an example of the possible research area. Finally, responses to mechatronics is coming into three levels and actions. The short-term levels, we already can feel it and sense it. This is going to use the existing technologies and synchronize it with the degree reflected by the background of the eco-mechatronics. And this coming through the research, already the outcome of the research that's already done, through the publications, through the books, through different organizations focusing on the issue of the environment, sustainability, and the circular economy and how to manage the ecosystem. We have the work on the medium-term responses and action, and this is normally implementing system that are reaching a final stage of their research in the time being, because we all know that there is a development and there is applying the development to real project. So this research are before reaching the project level and the industry. So this also is going to be evolved in the medium term, between 5 to 10 years, to see different new technologies, methodologies, algorithms, techniques going to adapt it to support the evolution of the eco-mechatronics. Finally, we have the long-term responses to an action for in the field that will be initiated with a new work, a new teams, new topics. Researchers are going to consider to reflect the key elements that I mentioned earlier, is the sustainability, environment, economic, and managing these through the circular economy. Thank you very much.
Thank you, MechE. A number of questions are coming in, so could I ask Peter and MechE to bring their cameras back online and mics back online, and we'll move to dealing with the questions. Okay, Peter, can you hear me?
Yes, David, I can hear you.
I'll just wait for Mackie to come and check there, and then we've a number of questions, one of which I find extremely interesting. But to start with, the first question is from, and apologies if I get the pronunciation wrong, it's Caetano Peng, and his question is about the cost of implementing Eco-Mechatronics, and could this be a barrier in many industries and sectors, and have we any idea of what are the basic costs associated with the implementation of the technologies you've been talking about? So, Peter, would you care to have first go at this, about the costs?
Basic cost, it's a very interesting question. Therefore, we have also to analyze for which companies it is relevant, because we have large companies, but we have also, especially in Austria, small and medium-sized companies, and therefore the cost for new technologies is a barrier. I cannot say a number on it, what are the costs, but one important aspect is that we are using existing components, existing data, existing knowledge in companies. And on the other side, you have to see what is the impact on energy efficiency, energy saving, and also related to the costs of energy. And also what we also see in this time and the discussion in Europe is the availability of energy or energy forms like gas and other aspects. And therefore, in the future, you have also taken into the consideration, it is planned in many countries in the world that we have a tax on energy, and this tax is also on the product, on the carbon footprint.
Peter, I'd like to move on. So, Mackie, do you have any quick comments on that?
Yes, actually, this is a very good question, actually, because the impact of any evolving technology is the cost. And if you look to the market, and the customers are looking for a cheap product, but they are not really aware heavily on the issue of the sustainability and the environment.
Anyway,
and as any basic research, actually, there should be a support from the government and the international organizations to fund such a research in order to develop a technology.
We've got a number of questions, so I'd like to move on. And Mackie,
but just to finish my answer in 2 words. Can I finish my answer in 2 words?
Finish.
Okay. So that's why there is a need for us in any basic research. There is a need for the government to participate and contribute heavily to support the industry to go in this direction, and in the time that is evolving to have a better cost and economical outcome. Thank you.
Sorry, I thought you'd finished. The next question, I think, ask you to start on it, Mackie, is from again. Apologies if I get the pronunciation. It's Haida Anjum, who works in the power transmission industry, and he's talking about the standards for efficiency in AC motors coming into effect. But do we have any examples of a circular economy in manufacturing that can be used to illustrate the change that this approach will have? So it's a question about, do we have any examples of applied circular economies in manufacturing?
Specifically in manufacturing, I'm not but in general, when you talk about the circular economy, we need to look into the whole chain of the process, from the idea generation to the design, the principle of the conceptual design, the material that's going to be used, the cost, and up to having the development of the product. And then from that development of the product is how, after the usage of that product, is how to come back through part of it through the recycling, and part of it so through the is how to use a biodegradable materials to go back to the environment without affecting negatively on it.
Peter's disappeared. I was going to see if he was wanting to add anything to that. I hope he will reappear in a moment or two. Anyway, we'll move on. Peter, you're back. Would you like to add anything to Maki's comments about the circular economy?
For the circular economy, currently it is mainly in the plastics industry, polymer processing industry. It is a very important aspect. Also to have all information about the materials, and you already maybe you know the digital product base, which also should support the circular economy.
Okay, thank you very much indeed. Now, the next question I'm going to take is from Colin Warburton, who says, the word smart is freely used. In my experience, smart is the new word for rubbish. Examples are motorways, meters. How can I have confidence in your smart items? I'm going to take the first part of this and say I actually agree with that statement. The word that smart has been hijacked in many ways and has resulted in people gaining false expectations over performance and what it's offering and what can be achieved. Unfortunately, there is little directly that we can do about it, except to reiterate the sort of comments that I've just made and Colin has made. In the longer term, it's a process of education, I believe, to make people understand what we're actually talking about in terms of achieving the sort of connectivity and interconnectivity that would enable, for example, a vehicle to directly pre-book a parking space to enable it to get there without having to drive around for 20 minutes looking for it. And if you want to have a look at what can be done on this, some of the work that's done by the MIT Sensible City Lab provides some very good insight into what a truly smart system, as opposed to one which uses the word to mean connectable system, actually can achieve. So that's my agreement, and get that off my chest, and I'll ask Peter or Maki if they have anything to add to my comments.
Actually, that's exactly what you said. But people use this one to classify human behavior, actually, in general, and to reflect that on the technological development. And the things is to mainly now what we can look at as smart technologies is integrating with our lifestyle in general. And the big issue associated with the development, actually, with fully autonomous cars, that can collect information, analyze it, make a decision, and go ahead with its performance and optimize its performance as possible.
Peter, do you want to add anything to the idea of what is a smart system, and how can we ensure that they are genuinely smart rather than just hijack the name for other purposes?
Okay. I think, David, you summarized the discussion, the aspects on smart. Yes, so no further comment from my point of view.
Right. Anyway, we'll move on then. The next question I'm going to take is from a Douglas Davis, who says that implementation strategy seems challenging and asks if there is much work being done in this area. How do we move forward to implement these ideas and get them to work in the real world? So, Peter, would you like to start on that?
Yes, this is currently the main challenge. How can I integrate this in the production system, in the production process, and also in the processes in a company. In my presentation, I have mentioned also this transformation process, not only digital transformation and sustainable transformation, also the agile transformation to help also the company to integrate this paradigm in their daily life. You are right. Currently, there exists no final version of such a process model, but currently also we in our research group have will work on different aspects to help to transform companies in this new way.
Maki, would you like to add anything to what we just said?
Yeah, actually, I mean, when it comes to the implementation, there are two levels. One is the use of the current technology, and there is not much actually to do with the Eco-Mechatronics aim, but through the research initiatives, specifically to form interdisciplinary international research groups that's going to focus on different topics within this area, plus to have international forums to initiate the discussion will be essential to build up the clear understanding and putting in new ideas and innovative development. Thank you.
Right, moving on then. The next question I'm going to take is from Stavros Yika, and he's asking, what is the impact on specifically governmental healthcare of Eco-Mechatronics? The fact that ever since it works in a hospital as a, I think I perhaps can take that as to start with. The situation in terms of healthcare and the application of Eco-Mechatronics is probably quite limited in the sense that the environmental impact of healthcare is not going to be as significant in the way that we're talking about in terms of, say, agriculture or manufacturing. Where Eco-Mechatronics is going to help in the healthcare environment, I believe, is in terms of providing support for people in mobility, in living independently. For example, work done to use robotics to help people live independently in their home environment is an area where the principles of the Eco-Mechatronic design can impact upon the way those systems operate in those environments. Yes, it's going to impact on the way in which you plan the utilization of space, the way in which you plan operations, the way in which you utilize your transport system. But it's going to be less of a significant impact than it is in other areas of potential application. So that's my reaction. Peter, Maki, do you want to add to that?
Yeah, actually, you know, in the medical field, there's a lot of tools used that are disposable and has hugely impacting the environment. Mm-hmm. And to develop something to replace these tools is very critical to avoid affecting negative in the environment anymore. Plus, also the issue of having, especially at the medical field, when you have a nano-robot, the development of nano-robotics, that will help a lot. With the nanotechnology will help a lot to develop a new medicine and a new way to facilitate to replace the operation, the surgery, into other level of things that avoid affecting human body, etc. negatively. So these issues are actually diverse way of application can be considered in this regard. Thank you.
Peter, do you want to add anything on the health side?
Not on this topic because it's not my main focus of applications of
I have a couple of questions that still remaining, which I'd like to get through in the remaining 5 minutes. This is from Eddie Simpson, who is asked Peter and Maki to indicate what they believe the challenges are in changing attributes designs away from doing less bad, i.e. recycling, towards doing more good, which is upcycling, when solutions may focus on only one part of the system, as for example, energy reduction. And as I say, I have one other question waiting. So if we can take this in the next couple of minutes, we can fit the last question in. So, Peter, would you like to start with this one?
There are different aspects. From my point of view, it is very important to have a holistic view that we integrate all different aspects for saving energy in the production. There you need directly energy, but also from the end of life phase, what I mentioned, there exists not only recycling of the material, it exists reuse, repair, refurbished, and so on. So it is an aspect here that we also have to discuss different end of life strategies, also upcycling or downcycling, and how can help Eco-Mechatronics on this.
Maki, would you like to add to that?
Actually, just briefly, it needs to have at the social level and at each individual level to have the knowledge and awareness of this issue, and also to have a critical political decisions, because government are responsible to have the initiatives, and that's why they need to make a critical political decision to support this direction.
The final question that I have is was one of the earlier contributors, Katiana Peng, and his second question, it reads, many parts of the world have no access and may lack technology and affordability. How can these technologies be extended to the world, bearing in mind that performance, efficiency, reliability, accessibility, and costs are critical? So, Maki, would you like to go in on that first?
Yeah, sure. I'm always supporting the direction of considering local material and local resources. It is not necessary to start from very high tech that demand a lot of money to support the development. You can consider local resources and support also the chain of the eco management can be started from that to support the development. So not necessary to develop a very high tech. And one of the things that I applied in my development of humanitarian demining robots is to consider local resources. Like instead of using a very complicated wheel and mechanical structures, I use the bamboo actually trees to form the wheels and to form the structure of the robot, etc. So there are actually local resources that can be contributed. Plus, there is a need also of international support from international organizations in these initiatives.
Peter, would you like to add quickly to that? Because I've got a final comment just come in that I'd like to get to.
Currently not. I agree with Maki's proposal and viewpoints on it.
Well, the final comment that has just come in relates to the question on healthcare. And it basically says, could manufacturing equipment in the medical field using more sustainable materials be the answer to the issue of in the medical field? And would that require collaboration in an interdisciplinary project from the Mechatronic and more specialized material engineers? As we've only a couple of minutes left, can I just answer that is already happening? Yeah. I've been working with a group in the UK, and they are already looking at how they can work with people like materials engineers to do exactly this sort of thing. So that is a very relevant comment. Looking at the clock, we have 1 minute left. So I have the duty of thanking Peter and Maki for their presentation, thanking the audience for their questions. They have been very interesting and stimulating in questions, and I hope that you have learned or found out something about the underlying concepts of what we're calling Eco-Mechatronics. And so, Peter, Mackie, would you like to have some final words of your own just to close things off?
I just would like to thank all of the audience and wish that they gain out of from this webinar. Thank you very much.
Peter?
I want also to thank the participants, and what we have also seen in the questions, it's a very broad topic where we have to work on very specific aspects and areas.
I think this final summary with Peter, there is not one single answer to all the questions. We've got to adopt an approach which allows us to explore on a broad front, and hopefully we'll find some answers. So my thanks once again, and thank you for spending the time to come and sit in on this webinar.
Thank you.
Thank you.